Okay, quick review. We're just going to do some simple inequalities. You get 2 days to work on stuff. Friday I'll have a short video, just a video lecture that you'll watch that'll cover compound inequalities. But let's get through this stuff together today. So linear inequalities, we know what the inequality symbols are, right? We can either have inequality symbols by themselves or with equal signs attached to them. No big deal. If we're graphing inequalities, if we're going to graph an inequality that has an inequality with an equal sign attached, how do we draw the endpoints of that graph? They're closed endpoints, so they're going to be solid dots, right? Closed endpoints. If they're inequalities without equal signs, they'd be open dots, right? So we don't fill them in. So let's try just a couple of these real quick. Like, what if I wanted to graph this inequality? A is less than -1, and let's say this is going to be on our number line. We'll call that -1. How would I graph that? Open circle at -1, and I'm going to shade to the left, or I'm going to graph to the left or the right. If I want the values less than -1, left, right? Lesser values on the number line always sit to the left, and greater values sit to the right, don't they? 5 is greater than 2, so it's to the right of 2, okay? So we would graph that way. How about this one? If that's 8 and x is greater than or equal to 8, closed endpoint, shading to the right. Good. Okay, so we've written these with inequality notation, right? The notation, the way we write them used inequalities. We can also write these another way. Sometimes in math we prefer to use a different kind of notation, so a different way of writing them, called interval notation. Interval notation, the ingredients of interval notation, it looks different. It uses infinity symbols, parentheses and brackets, and then a comma. And the way we do it is this. It's easier to think about interval notation when you graph it first. Now let's look at the graph of this red interval. When we write something in interval notation, we always put a comma in the middle, and then we're going to describe that interval. If the ant could only walk on the red interval, that's what we're talking about. We're trying to represent that using interval notation. To the left of the comma would be the left edge or the left endpoint of that interval. To the right of the comma would be the right endpoint or right edge of that interval. Well, what's the right edge of that interval? What's the furthest that an ant walking on the red region could go to the right? -1, okay? Good. What's the furthest the ant could go to the left? -infinity. It can go forever in the negative direction. Okay, now the other part we need to include is we have to, with each of those two parts, we have to include either a parenthesis, which is rounded, or a bracket, which is squared. How do we know? Well, a parenthesis indicates an open endpoint where we're not including the endpoint. A bracket would mean that we are including the endpoint. So what goes with the -1? Parenthesis or bracket? Parenthesis, right? Because we're not including the endpoint. It's an open endpoint. There's no equal sign in our inequality. Okay, give me thumbs. Does that make sense? Okay, so we get parenthesis. Now let me ask you a question. If the ant's walking to the left, can the ant ever get to -infinity? No. It's not a place you can get to, right? So because the ant could never get there, could we actually include that as an endpoint? Is that an endpoint? No, So infinities always go with parentheses. They could never go with a bracket. To include a bracket by an infinity makes no sense because it means you can somehow include that point, which you could never do because you never get there, right? So that's how we would write that interval using interval notation. Okay, give me 1 to 5. Does that make sense? Okay, so again, we start with the comma in the middle. Left endpoint on the left, right endpoint on the right, and then you either choose parentheses or brackets, okay? How about this one, the blue one? What goes to the left of the comma? 8. With what kind of enclosure. A bracket, because we are including the endpoint, right? That's filled in. What goes to the right? Positive infinity, because it goes forever. The arrow means it goes forever. And that has to go with parenthesis. Good. You got it. Okay? That's interval notation. No big deal. Now there's an easy way to keep this straight. What goes with what? All the blue stuff goes together, all the red stuff goes together. All the stuff that requires more ink goes together. It takes more ink to draw that extra equal sign on the inequality. It takes more ink to fill in the dot, the endpoint, and it takes more ink to draw a bracket than a parenthesis. Everything that requires less ink also goes together. Okay? So when we solve inequalities, and that's what we're going to take a look at next, think back to when you solved inequalities in the past. It's just like solving equations with one exception. If I multiply or divide an inequality by a negative number, both sides, what do I have to do to the inequality? If I have an inequality and I multiply or divide both sides of the inequality by a negative number, what's it do to that inequality? Flip-flops it, doesn't it? Yeah. So it's going to flip it around. Okay, that's an easy thing to forget. Okay, let's try just a couple here real quick. Oh, and just a quick reminder. So this is, again, this is inequality notation. That's just when we actually use inequalities to write down an inequality. Interval notation is when we're using the stuff we just talked about, right? We won't really worry about set builder notation. Okay, so what would I do to solve this? Just like an equation, solving means isolating, right? Can I just isolate my variable is m? Can I isolate m right away? I can't. How come? What's going on? Piper, how come I can't just isolate m up there right away? Because I can't what? What do you think? I can't point to single variable, right? There's two variables there, right? So I have to do some simplifying first. What does that amount to? Okay, I've got to distribute on this side, don't I? I distribute the negative, so that's going to give me 3 minus 4m minus 1 is greater than or equal to 5m minus 25. I can combine like terms. 3 minus 1 is 2. Minus 4m is greater than or equal to 5m minus 25. Now what? Okay, I'm going to move the variable to one side. Where should I probably move the variable? To the right. I mean, either way would work, but we'll move it to the right so we get a positive number. But again, either way would work by adding 4m to both sides. So I cross the variables off the left side. What else might I do at the same time to save a little time? But I'm moving the variables to the right. So what do you think? Okay, good, because I want to push the numbers the other way then, don't I? Right. So those are going to go over there, which I would do by adding 25 to both sides, which is going to give me 27 and 9m. Okay, last step. Divide by 9, good. And that's going to give me, so I'm going to scoot up here so I have a little more room. So I'm going to get 3 on the left and m on the right. That's correct, but when we write inequalities, we'd rather have the variable first on the left side. So what could I do to that inequality to rewrite it with the m on the left? Flip the whole thing around. Now, if I were to read this, I would start with the variable. M is less than or equal to 3, but I want to twist the whole thing around and make it look like that. It's like if I were to write this on a glass, like one of those biology slides, you know. If I wrote that on a glass slide and then I turned it around, everything would get twisted around, including the inequality. Okay, give me thumbs. Does that make sense? Okay, so that's my result. How would I graph that? If that's 3, where would it go? Solid, endpoint, and we want the values to to the left. So using interval notation, what would that look like? Okay, on the right side I've got 3 with bracket. On the left, with parentheses. If I got those mixed up, do you see that that wouldn't make any sense? Using interval notation, I always have to have greater numbers to the right and lesser numbers to the left, just like a number line, so it matches a number line. Okay? Okay, what about one like this? Again, I can't point to a single x, so I would have to do a little bit of simplification. Wouldn't that mean just distribution here? So if I distribute, I'm going to get 48x plus 16 is greater than 48x minus 160. Now what? You're right. Subtract what from both sides? 48x, right? I'm going to try to push the variables to one side or the other, but when I subtract 48x, they go away. Okay, now the math gods are saying something very important there. If the variable disappears from an equation or an inequality, what are the math gods telling us? Maybe. Maybe. They're telling us that x doesn't matter in this case. The value of the variable doesn't matter. Either one of two things is going to happen. Either every possible value of x is going to work, or none of them are going to work. If the x is not in the answer, there are not going to be specific solutions. It's going to be one of those two things, right? Well, which one is it? Do all of them work or none of them work? Is that true or false? That's true. So they all work, don't they? So the answer is all reals. Every real number would be a solution here. The value of x makes no difference. Okay? Give me thumbs. Does that make sense? Okay, that's just like what we dealt with equations, isn't it? Okay, last example. Same kind of a thing. What if I distribute here and I simplify? I'm going to get 6x minus 4 on the left. I'm going to get 3x minus 12 plus 3x. Let's skip a step. 3x plus 3x is 6x. Just like before, I would subtract 6x from both sides. Okay, the x's went away, so what are the math gods telling us? Well, maybe. They're not specific yet, right? If the variables go away, they're saying x doesn't matter, right? So is this true or false? Is negative 4 less than or equal to negative 12? That's false, isn't it? Right? That's false. So because that's false, this must be a no solution case. Okay? Make sense? That was quick. How about that? I'm done. You can work the assignments up.